is still insertion sort. So it's supposed to be, it's pa kind of ironic that it's supposed to be an improvement of the insertion sort. You know, everybody knows insertion sort. So it's an improvement of insertion sort, but its last process is insertion sort. So we will see how it is through a given example, not necessarily the code, because I'm sure you can follow codes. You're a CS student, and I expect you to be able to write codes in C, and somehow we'll try to see kung kaya nato buhaton si Python. We can incorporate Python here, especially when we are dealing with arrays. If you notice, in sorting algorithm, we are mostly dealing with arrays. We'll try to see if we can incorporate Python so that somehow when you move on to the next level, so you have an improvement of knowledge. I mean, you have additional knowledge. Although we will attempt na po. We did attempt that in PL last semester, but we will not attempt siguro this sem. We will do it this sem. We'll try. Ay, this sem naman. Next sem, hopefully. Depende di ay kung ako teacher or not. Depende pa di ay. Okay, anyway. So, we'll try to do that. And by the way, if you still have friends left behind in data structure, palihog in town, tabangin in town to ninyo. Pagka problema, dili sila kibahong mo access, dili kibahong mo drawing, mas na-stress na kid ko. Na-stress ko ganina. Let me express my being stress para mawala ni. I am handling all data structure section. Malipay kay kog maghati mi ni Sir Gran. Malipay kay kog maghati mi ni Sir Gran. I'm handling all data structure, 4 sections of data structure. And then my MWF is all data structure. Imagine from the morning until 4:30. Data structure. Tulo ka data structure. This sem wala. This sem wala. Last sem, sometimes. And then, so malipay ko kung maghati mi ni Sir Grant. But then, anyway, we have new admin, they have new thrust. I think limiting the number of, limiting the number of preparation for teachers. Dili pwedeng beyond 4 preparations may. I think that is the thrust of the new admin because of the coming PASCO accreditation. So naasad mi requirement nga dapat dili daghan kay preparation. And then so mo na siya. So I have three data structures MW and one data structure Thursday, so before your class. There are only 16 students or 17 students. Dili man mong answer gamay ra mo answer. Oh my goodness niya. Ang akong gipangayo pa ganina kay insert first ra ug insert last nga linked list. And then siguro ang i-answer mga 5 ra out of 16. Insert first ug insert last now. That's because I need them to translate it to cursor base. Pero very good. Kay naara gyud naka-translate na ay first year student, ay first year na ay first time sa data structure na naka-translate gud siya to someone gave me a release function header pero ang giko linkless. Ang mga answer nila kay mga karaan nga data structure. Sorry. Mas again, at least na lang usa to show the repeaters that kaya siya sa first timer. So naay first timer nga naka-write good og insert last sa cursor-based implementation. So that means using pointer to an integer nga traversal. Nga rapot. Anyway. Sige. Let us start. Okay na ko. Kapahungon ako. Okay na ko. Sige. Na-stress na ko so. We'll see. Dili. If we have time, then we have to move on. Dili necessary siya idungan, but ano lang siya, magsunod lang sila para we can recall. Para we can recall the characteristics. We'll try to see lang at time. Sige. Okay, so this is now Radix sort. Go. Ah, si Cashmel naman di ay. Okay, Cashmel. So it's not
Hello.
John. John finished. Yes.
So, good afternoon, everyone. Today I'll be
Mm-hmm.
talking about Radix sort. So, what is Radix sort? So, if you think about it, if you've mastered counting sort, you'll probably master Radix sort fast set. So, what is Radix sort? So, Radix sort was believed to be found like at 1887 by Hermann Hollerith with the tabulating machines. But the very first implementation of it in computer form was made by Harold H. Seward in 1954. Now, Radix sort is considered as a stable sort. So, as a refresher lang, stable sort preserves the order of the elements if they have the same keys. So, the relative order of any two items with the same key is preserved after the execution of the algorithm. So, let's say I have an array of 12, 2, and 22, and we are gonna sort it using the key of 2 in
So
its ones place, so it still preserves the order, which is 12, 2, and 22. And
before you
it is,
sige,
yes,
continue. Sorry, sorry. Just continue. Sorry. Okay, just continue.
okay, so Radix sort is also considered as an out of place algorithm. Out of place because it is similar to counting sort, where we have to create another array to do the, the algorithm. So
Okay,
give it,
before you
yes,
go,
miss,
before you start with the simulation, I would like to ask, what is the English meaning of radix?
English, yes.
Nag-Google na tayo. Muna yun yung advantage, no? Kung, kung online. Okay. What is the English meaning of radix? Because that will help somehow the name of the algorithm is based on what it does. Kaya kung
Radix
counting,
meaning the base of a number, miss. So
yes.
so you basically base it by its ones, tens,
Yes.
hundreds place.
Base. So it's another word for base. So is that how you're going to sort? Is it based on the base?
Yes, miss.
Yes. Okay. So at least you know why it's called radix and relate it. Nga radix ang iyang name. So it's because it's radix means base. So and since we're doing a decimal system, so ang basis nimo kay ones place, ones, hundred, tens, tens pa pala, tens, hundreds, thousands, and so on.
Tens.
Okay, sige.
Okay.
Go,
Okay.
Kashmel.
So an example for a simulation. So given an unsorted array, 121, 432, 564, 23, 145, 788. So the first thing you usually do in a radix sort is to find the maximum digit. So in this case, among the array, you see that the largest digit in here is 3. Has three traces, the ones, tens, and hundreds, so 3. So which makes it, let's say, D as digit is equal to 3.
Wait, wait, wait. You were saying that the first step is to find the a maximum digit,
The maximum
maximum
number,
number of digit.
number of digits, yes.
Ah, okay. The maximum number of digits. So go maximum number. Go next.
Okay, so the reason why we have to find the maximum number of digits is it is used to it is used so that we will know how many times we have to loop throughout the process. So you'll be doing it 3 times. So first would be the ones place. So you basically just do a counting sort. So you count the number of keys that are present in each element, and you put that in the count array. So one adds to the one place. I mean, the first index of the count array, two in the second index of count array, and so on and so forth. Basically, just counting sort, but with the ones place. And afterwards, in the counting sort, you usually either to get the relative position for the auxiliary array. So for that, you have to just the basic counting sort where you have to manipulate the said count array. So you subtract one from the first, I mean the zero index. So so you do the manipulation of the count array so that you can get the auxiliary array, just like in the count sorts. So first index would first index would be the sum of the first and zero index. So you do that, you loop through the count array, manipulate so that you get the position. So, so it would look something like this. After that, after getting the after manipulating the count arrays, you can then put the input array to the auxiliary array. So for the 788 na element, it tells us na the key would be the eighth index of count array. So it tells us that 788 belongs to the sixth index of the auxiliary array. So 788 goes to the sixth index. And then afterwards, you decrement the value by 1. And then 45 with the key 5 tells us that 45 belongs to the fifth index of the auxiliary array. And then 1 belongs to the first. 23 belongs to the third. Fourth belongs to the, I mean, 564 belongs to the fourth array. And then 42 belongs to the second auxiliary array. And 121 belongs to the index 0 of the auxiliary array. And then, di ba I said na we had to do the loop 3 times. So, because the maximum number of digits is 3. So, what we will do is use the auxiliary array and use that as an input for the next loop. But this time, we will be checking the tens place now. So, I will not be doing the entire loop because we already know how it goes. So, it will look something like this lang para fast forward. So, you count the second the tens place, I mean. So 1 to 1 to account increment the second index of count array and so on and so forth. So it looks something like this. And then this is the second loop. So the third loop, you put that and then you count the keys, respective keys in the hundreds place of the array, I mean of the elements. And then you do the similar counting sort algorithm, and then that will yield us with this result. So after that, it's already sorted, which is 1, 23, 45, 121, 432, 564, and 788. So basically, in its basic form, Radix sort is just counting sort, but with extra steps. And those steps is that you have to count the number of maximum digits, and instead of sorting them instead of sorting them as a whole, you sort them by their digits. So for the internet code and the group code, it will be G and Marco Perol who will be explaining.
Uh, Let me present lang guys. Hello, I am Gian Pearl, and I'm gonna talk about the Radix codes. So, uh, first step in first step in Radix sort is to find the largest number, so we can find the number of digits. So here we have the two examples of Radix codes. So here we have the function getMax, which is used to find the biggest element in the array. So we can see here that both codes from the internet and our group codes are similar. So the next step is to apply a sorting algorithm to sort elements based on the place value. So basically, the algorithm uh, the algorithm we're going to use is the bucket sort, so which has been tackled already by my group mates. So the difference between our code from the internet code is that the implementation in the internet code is through matrix, while our group code is through the array linked list. So here we try to use the getMax, and we used the getMax function earlier to find the biggest number. Then we create n number of buckets that can hold the values for all buckets. Then for all the buckets, we initialize each with null. So here in the internet group, they used lar, or like the largest number, and NOP for the number of digits to find the significant figures. But in our group code, it is part of the it's in the while loop. So here it then loops the array. Then we implement the insert last linked list. Then we place the elements into the buckets with its corresponding index. Then in this for loop, we gather the elements from each bucket to the array. So then here, this loop, the bucket sort ends, and the loop continues until the largest number is greater than zero, while it's greater than zero. Okay. So here we have the Radix sort variations. So there are two basic variants of Radix sort, which differs in order, which will look at the digits of the elements. So first is the LSD Radix sort, which is also called, which where LSD also stands for the least significant digit, and here we start sorting at the least significant digit, and work our way up digit by digit to the most significant digit. So let's say from ones to tens to hundreds and so on. The next we have the MSD Radix sort. So we can also start with the most significant digit, where MSD stands for the most significant digit, and we work our way from the most significant digit to the least significant digit, from hundreds, for example, all the way to ones digit. So next is the time and space complexity. So here, since Radix sort uses other sorting algorithms, the time complexity may vary. So for average case, where elements have a distribution of different digits, its time complexity is O of nk, where n is the number of items to sort, and k is the length of or like the number of digits. So, and for the best case, we also have n O of nk, where all elements have the same number of digits. And for the worst case, where all elements have the same number of digits except for one, with a large number of digits, we also have O of nk. And its space complexity is also is O of n plus k. So I think that's it for Radix sort.
Okay. So, so as I've told you that the sorting algorithm is one of the easiest. So there. So I think, are there any clarifications? Wala, no? Sa'yo naman ni Kais sila. There are simple ones. So it's like for your information lang. In this case, so internet code usually use arrays. In this case, they introduce linked list for buckets. Okay, anyway, sige. We'll go to before we proceed na lang to the next. Shall we have the illustration simulation of group 2 cell sort?
Yes, yes, mate.
Sige. See, the objective of the simulation is for you to remember the process. When there was even one time that I asked the students, so compiler, algo and complexity pala, to dramatize the sorting algorithm. So para they will lang remember how it is done without really Googling like what you do, especially when you're asked a question about it. Sige, anyway. Go every. Sige,
Makita
go.
na, miss.
Yes, Rai.
Okay, thank you.
Ayun na may taga-code. Sige, go. So which one is shells? Which one is Nuth?
So today we will be seeing the different variations of shell sort algorithm. So we will be starting with the original. So today we will be seeing the different variations of shell sort algorithm. So we will be starting with the original one from shell. So the starting of the interval for this version would be the size of the array, which is 10, divided by 2, which is 5. So we can start comparing two elements with the interval 5. So that would be index 0 and 1, 2, 3, 4, 5, and index 5. So we will be comparing 73 and 41. Since 73 is greater than 41, we will be swapping these two. So 73 is now in index 5. So we will try to see if there are elements that we can compare to 41 on the left using the interval 5. Since there are no elements to the left of index 0, we will retain 41 to index 0 and move on to the next comparison, index 1 and index 6. Since 67 is less than 83, so they will just retain their positions and move on to the next. So we will be swapping these two and retain 37 to index 2 because there are no elements that we can compare 37 on the left using interval 2. So compare index 3 and 8, which has the same value, so they will just be retaining their positions, and move on to the next and swap them since 52 is greater than 10. At this point, we have reached the end of the array, so we will be decrementing our interval by dividing it by 2. So 5 divided by 2 is 2. And we will be comparing index 0 and index 2 since 41 is greater than 37, so we will be swapping that and move on to the next iteration. So here we are comparing index 2 and index 4 since 41 is greater than 10, so we will swap that. And since 10 is to be assumed to be inserted on index 2, but there are elements on the left of index 2 that we can compare to 10 using the interval 2 because we have 1 and 2 elements on the left, so we can compare 10 with index 0 that has the value of 37, and we will be swapping those two. So since there are no elements on the left of index 0 that we can compare to 10 with using interval 2, so we will retain 10 to index 0 and move on to the next comparison, which would be index 3 and 5. So we will be retaining the positions and move on to the next. So swap, and here also, so index 5 has elements on the left that we can compare to 56 using interval 2, which is 1, 2. So we will be comparing index 5 and index 3. So we will be swapping those two, and we can compare index 3 now with index 1 with respect to the interval that we have. So since 32 is less than 56, we will be retaining their positions and move on to the next comparison, which is 6 and 8. So swap, and the same thing, we can compare this to index 4 and swap and compare it to index 2 and swap, and then compare it to index 0 and retain the value and move on to the next comparison. So 73 and 52, we can swap those and compare it to index 5, swap, compare to index 3, swap, and then compare to index 1. So at this point, we will just be retaining their positions. So here we have reached the end of the array. So we will be decrementing our interval again by dividing it by 2. So 2 divided by 2 is 1. So at this point, we will start our comparison by index 0 and index 1. So that would be 10
Can you
and
stop
32.
there,
Retain,
Ryan?
move
Can you
on,
stop? Can
retain.
you stop? When your interval becomes one, that's already insertion sort. So you can just say, that's already insertion sort. Or is the process different than insertion sort?
It's
Because
the same.
interval is already one.
Yes, madam, it's the same. It's an
So
improvement.
since it's already insertion sort, then you can just tell them apply insertion sort and that's it. That will be the result. You don't have to simulate.
Okay, madam.
So, 'di ba? If you recall insertion sort, you will just like compare the first element and then shift the next element. Everyone knows insertion sort, right? And there are two versions of insertion sort, the one that will swap every comparison and the other one that will shift comparisons. Most of what is found in the internet is the shift one. You follow? Sige. Okay. So we can stop there and then go to the next. But we don't waste time. So if you feel that it's already known, then you don't have to go through that. Sige. So this is shell sort using Nuth. Go. Okay. Okay. Sige.
So today we will be seeing the different variations of
This is a
2 is
problem that
already
you're going to
0,
face.
so we will be stopping our algorithm and it. So today we will be seeing the different to index stopping our algorithm and it we have already sorted our array and it took us 19 swaps to sort this array and 3 iterations of our interval from 5 down to 2 and then 1. Now let's see the NUTS version for this algorithm. So in this version the interval would be depending on the number sequence that we have here. So the starting interval for this version would be the biggest number of this sequence that is less than or equal to the size of the array. So since our size is 10 and the biggest number that we have from this sequence that is less than or equal to 10 is 4. So we will be starting from 4. So to do that, we can now compare index 0 with 1, 2, 3, 4, index 4. So we will compare 73 and 52. Using the same concept that we have earlier, we will be just swapping this 2 and then compare index 1 and 5, swap 2 and 6, retain, and then retain, and then swap. So here we are in index 4. We have elements to the left of index 4 that we can compare to 32 with respect to our interval. So we will be comparing 32 with index 0, which is 52, and we will be swapping those two and move on to comparing index 5 and 9 and swap. So here we can compare 10 with 41 of index 1, so swap and then retain 10 to index 1. Then here we have reached to the end of the array, so we will be decrementing our interval by dividing it to 3. So 4 divided by 3 is 1, and so our interval at this point is 1, so we will be comparing index 0 and index 1. So swap, and then 1 and 2, retain, 2 and 3, swap. So compare this to index 1, which has the same value, so retain the positions, and then compare index 3 and 4, swap, and compare it to index 2, retain, and then compare 4 and 5, So we will be swapping this and compare 41 to index
Try
3
stop, Ryan. Ryan,
because
stop.
again,
That's also insertion sort already. So stop para we can move on to the next. So can you explain exactly what is the difference between shell and Nuth?
Um, the difference between shell and note is that with notes there is already a set there's already a set sequence set by Donald Knuth. Meanwhile, when using the original version of shell sort, you will be depending the interval on the half of the original of the size of the array. So
So
it will vary.
J, okay, J, in other words, they only differ in terms of interval, how the intervals are derived.
Yes, madam. And also,
Okay.
when it if the number of elements in the array increases, the growth in number of passes when using shell sort, the original shell sort is also faster growing compared to nodes. So it will take less passes when using nodes as compared to shell sort original.
The Snoot has a basis for this.
Yes, madam, in his book, The Art of Computer Science, in
Yes.
his book, dated 1998, uh,
Mm-hmm.
uh, uh, 1998, madam, in his book, The Art of Computer Programming.
That's new. That's a new book already, 1998, because Knuth is one of the really respected um, computer scientists in terms of algorithms.
Yes, madam.
Si Donald Knuth, Don, or sometimes they called Don Knuth or Donald. His complete name is Donald.
Uh, the,
Okay,
the edition
sige.
I got is from 1998, madam.
Okay, so my next question is, um, since you said that there are predefined intervals in Knuth, so is it stored in an array or is it computed?
Uh, there are,
Predefined naman siya.
uh,
Can
it can be derived using a formula, madam.
okay, so it's not predefined. It is based on a formula.
Yes, madam, but it is it is defined by a formula, but it can also be stored in an array. Uh, it is already defined, so
Okay,
not, uh, yes, madam.
sige. So you said that it can be just computed. So in that case, you have 10 elements from 0 to 9. So how was 3 derived?
Uh,
How was 3 computed? Di ba you started with interval 3 sa Nuth? And then after, sorry, 4 ba to?
four, madam, four.
4, 4. After 4, you
Or then
have
one.
then 1.
Yes, madam.
So how is it computed if it is not stored in an array?
Uh, it is it is defined by the formula inter uh,
Can you put
uh,
that in chat?
yes,
Can you
madam.
put that in chat? Sige. So when you're going to program and you're going to use Nuth's procedure or process of doing shell sort, then you can use that computation. Interval is equal to, but what is the value of interval?
The interval is the previous one, madam. The previous
Yes, but how do you compute? How do you determine 4 in this case?
for the for loop is this one, madam.
So
Uh,
it's a loop.
yes, madam. It
Sige.
is
Anyway, it is found in your algorithm.
yes, madam. It is
Okay, never mind. Sige. Naasa example na daw. Okay na lang daw. And unsa na siya? One interval is less than n, where n is the size of the. Okay, sige. Okay, no problem. Just put it there. Where n is the number of elements. So finding the interval. Okay, thank you. And then the other one was to define. How do you determine the next interval?
It the next so so the determination is first get the maximum
Yeah.
interval,
Yeah,
then
that's the
divide.
loop, right?
Yes, madam. The
It's a
first
loop.
yes, then for the subsequent passes, the interval is divided by three for every pass. So
So
first,
it's always divided by 3?
yes, madam.
Okay, sige. Okay. Okay, Nijay. Do you have some questions, the others? Do you have some questions? Clarification? Did you get that one? So, ano na good sa number of intervals? Ang kang shell is straightforward, but in effect, the more the number of elements to be sorted, there will be more passes. They call it passes, and then whereas Nuth has fewer passes. So in this example, what is the running or how many swaps? How many swaps are there using shell and using Nuth?
For uh,
11 yata niyo. 11 ang kanina 18
uh,
o pila naman na?
18 and 17, I think 18 and 17. Uh, from what I got from Aiza, it was the difference is only one in these examples. So the difference is only by one, but as the number of elements grows, so the difference will grow larger as well. It, the uh, as compared when using newts as compared to using the original shell.
Okay, so back to my question a while ago that shell sort ends up with insertion sort. So what is the advantage of using shell sort as compared to insertion sort? What does it do?
For shell sort, the main advantage is in cases wherein the original position of the element is far from the intended position in its sorted form. So if the distance is very large, so there would it would need more swaps. It would need more shifts in order for it to reach its intended position, and also according to the book of Donald Knuth, the main component for the main determination for running time is the number of swaps for the algorithm. So the lesser the amount of swaps, the more efficient the algorithm is. So since the the swap the distance of travel for the element is larger in shell sort, so it would lessen the number of swaps, thus uh, making the process more efficient in the long run.
Okay, thank you. So in other words, so for example, if you have 15 elements and the last element is a 1, and the final position of 1 will be at index 0. So in insertion sort, in the last iteration of the outer loop, that one will have 14 swaps if you're using a swap from the last position to index 0. But using shell sort, that one will move forward or will be it could be at index 0 or it index 1 in the first phase palang. In the first phase. So fewer swaps and fewer comparisons. It's already in its position or close to its proper position. If you have small numbers at the end of the original array. Okay, thank you very much. Are there questions? Wala na. Sige, klaro na. Si klaro na si shell sort. Sige, okay. And thank you for your illustration. So that is a good preparation though for international presentations wherein you already make videos, but for algorithm and complexity, I would prefer that you do presentation first because you are not allowed to do videos during your first presentations for proposal that will be next semester. So mag-practice na ta din mag-practice na ta sa so it's like proposing so proposal for something. Okay, so after that, then you can practice also doing videos for presentations for international conferences. So karon ani sa ta. And then question, answer, mas lala pa ang mga lala pa ang panelists. So there are three. Imagine there are three of me asking question. So ako ra usa karon. So in your proposal hearing, tulo na kabuk ang mo ask of question. The chair of the panel and then the two panelists pa gyud. So anad-anad na lang mo. Kamay ra bitaw. O sara bitaw ko karon. Okay. Sige. Anyway. 'Di ba? Cashmel? Lala pa no? Tulok buhok cashmel. Tulok kabok mo ask question o think ka. Anyway, okay naman mo help man ang mga panelists. That is the purpose of the panel naman to help you, not to scare you, but to help you improve your research. Okay, sometimes limit the scope, sometimes enlarge the scope. Basta they ask question to know kung you really know what you're doing. So, muna atong gi-practice karon. So in the future also, this is also a practice that you need to present something in a way that sometimes you can go directly to an answer, not go around the bush. Or do you do that because you don't know the answer yet? Anyway, just continue. Okay, we go to the next sorting algorithm. So, sige, the next will be, wait, what's the next? Okay, so we will have gnome sort. Dali naman puting gnome sort. Mga kaligar Maninila. Sige.
Hello. Okay. Can, Good afternoon, everyone. We here is Gnome Sort brought to you by Team Stupid. I am Eric Saldran, and here with me are Raymond Ayay, Jomer Bersanilla, and Kevin Marte. So first off, why are we called Team Stupid? But we would like to introduce to you a person first. He is Mr. Hamid Sarbasi Azad, a professor of computer science and engineering at Sharif University of Technology. So why are we called Team Stupid when it's a gnome sort? Well, gnome sort was initially called Stupid Sort when it was proposed by Mr. Hamid. He published this in their CS department newsletter, and then on the right here, the picture you can see the note that he published. The sort was then first called Stupid Sort. Then it was then renamed or later described by Dr. Dick Groen, who is a Dutch computer scientist, renamed it to gnome sort. So why gnome sort? Gnome sort is based on the technique used by the standard Dutch garden gnome. This is where the garden gnome first looks at the first flower pot and then looks at the next one, and then compares if they are in the right order. And then if they are in the right order, he then steps forward one pot. And if it is not, he swaps them, they swap the places, and then he moves backward to check if the previous one is also correct. And then the process will then repeat. So if you're familiar with insertion sort, it is very similar to that. However, what the difference is, it's only using a single loop. Next, we have Jomer, who will be explaining to you the code and how it works.
So here we have the original code created by Hamid Sarbazi Azad, and it is written in Pascal. In the first part of the code is the creation of the data type called a type, which is an array of integers which starts from the index 1. Next is the declaration of the variables, and which is the array for a and n for the integer, and we have I for the integer as an integer, which is the for the position. So in Pascal, every block is enclosed with a begin and end statements. The begin statements marks the start of the executable portion of the block. So inside the block, the variable I is initialized. So if since the array starts with 1, so it is initialized with 1. So and just stated before, the gnome sort only has one while loop and is not recursive, so it only uses a single loop. So inside the while loop, there is an if and else statement, and that has a condition to check if the current position is less than the next position. And if that condition is met, it will swap the values of the current position and the next position. After that, it will decrement the variable I or the position to swap the values of the current position.
Again, please stop that one. You are CS student and you're supposed to know that one. I would just like you to illustrate one big example and show us the process.
We will do that in the next.
So skip that one.
Okay.
You are CS student. Whether that is in Pascal, you can figure out because you can
So
figure out. So go directly to the process.
in the C implementation, it's
You
just
meant
the
yes.
same, and Python also.
Go directly to the process. Let them understand the process through your presentation rather than through the code. So maybe you can go to the process first and they would understand or they would remember time complexity and space complexity if the process is being understood. So you mentioned there's only one loop, not a loop within a loop. How is that possible? When insert you mentioned insertion sort, it's the same as almost the same as insertion sort, but insertion sort has two loops, loop within a loop with a running time of O sub n squared. So how is this case? Running time is also O sub n squared. So how is it done? Sige, go. Maybe you can give a bigger example or a longer example to showcase all positive case test case scenarios. Ayaw lagi magtagaig. Ano, you explain it. Don't give us a simulation of a code. Give us an example. How it is done. Describe it, not simulating the code. I mean, showing us the code. We've done this one last semester, last meeting. Now I want you to explain the code explain the process based on an example. And a good example at that so that all possible cases will be uh, will be showcased in your example. So parang wala ta ni-learn sa lesson. That was what I commented last Tuesday. And you did not bother like change it to improve your presentation. That is bad. You've seen already the effect of the first group and you did not bother change it. So di mo adjust. You don't make adjustments based on what was mentioned in the first group. You need simulation. Para kasing you are also a student and simulating a code is like parang feeling that you cannot simulate, you cannot do that. Really stop. You are CS student. You're not other student. Need simulation. Even if you're given a code in Pascal, you can figure out because you can even figure out if you're given a code in pseudocode. So it's the process that I want you to showcase. Again, it's an insult to see a student to be taught how to simulate a code. We go to the next. We go to the next group. We go to tournament sort.
Okay, Miss Witsa.
Hello, everyone. Good day. Our group is going to discuss tournament sort. It's me, Ralph So, John Pasana, Jameson Perez, and Ashley Tan. So, tournament sort. It was developed by Alexander Stepanov, a Russian computer programmer, and Aaron Kirshenbaum in 2002. So, the original version. It was the tournament sort is a selection sort, but it uses a priority queue. It is also a variation of a heap sort. The name tournament sort came to be because it is similar to the single elimination tournament, wherein um, a group of teams will have to go like one versus one until one becomes victorious, and it is like a tournament because they have the winner goes to the queue, or like the winner advances forward.
So I'll be talking about the space complexity of a tournament. So, um, put it next, John. Yeah, thank you. So the best case, average case, and the worst case time complexity is of a tournament sort all O n log n. So it uses a time complexity of 0 n to initialize a tournament and O log n to select a minimum element of n elements. The size complexity of a tournament sort is O n.
Okay, so
That's all? Okay.
we'll get to that one, the main meat of the algorithm. So we'll just be showing how it works through through drawings. So basically, you want a an array to be sorted. So what you need for when you're gonna do tournament sort is you need a heap and an array. So they're separate. So what you're gonna do is you're gonna make them compete. You're gonna make the numbers compete. So first we're gonna place numbers into the bottom of the heap. First 12 and 5. Okay, we'll put the rest. Now it's full. So what we do is we make them compete. So what we want to find here is which is smaller. So 12 is less than 5. I mean 5 is less than 12. So 5 goes up. And here 1 is less than 3, so 1 goes up. And then we make these two compete also since it's a tournament. So 1 is less than 5, 1 goes up. Now we have a clear winner. So what we do is we output 1 into a list, to a separate output list. So since 1 is the winner, we'll remove it from the heap. Okay. And then we put the next person from the, number from the array into the place where 1 was. Can you hear me?
Yeah, can hear
Okay.
you. Sige.
Sige. So we make them compete again. 3 is less than 4. So 3 is clearly less than 4 and it's also less than 5. So it's the winner and we put it into the output list. And remove 3 from the heap. So now we have 2. But as you can see, 2 is a, if we put, we know that 2 is going to win because 2 is the least of among everything here, but it will be unorganized because 2 is clearly less than 3, which is the last thing that was placed. So we have to compare 2 or whatever and new integer from the last thing that was placed in the output list. So we make sure that everything is in order. So now we know 2 is less than 3. We disqualify 2 from competing. So since 2 is disqualified, 4 will move on. And since 4 is less than 5, then 4 is the winner. And we put 4 in the output list. And then we continue this. 5 is the next one. Remove. Next, compete. 7 is the next one. Okay. 8 and 12. And now 2 is remaining in the output list. I mean, in the heap. What are we going to do about 2? So we have to put it into another output list. And we do the tournament again. We do round 2 this time. 1 versus 2, 3, and then everything. Again, the whole thing goes back again. And you have your sorted output list. So you can either do, actually there are other ways of doing it. You can either make it do the tournament again, or there's a type of sort, a merge sort, but we're not handling that. So that's just another way of like solving this problem in tournament sort. So that's the example of how it works.
So you're talking about variations in tournament sort.
Uh, Not necessarily. It's like an
So
added.
so what is really tournament sort? Is they're merging in tournament sort.
Oh no, like since it's two lists, you can. That's just another way of doing it. Like from what I've
But the
seen in the.
original tournament sort, what does it do?
Oh, in the original, you make them do a tournament again. You do another or another round. So you do 1 and 2, and then compare. Then one goes up, one here. So you just basically do everything here again, but with two output
With two
lists.
lists? Coming from two lists?
Yeah, yeah, two lists.
Okay. Okay.
So that's
Jamestown. Notice that when one is removed, for example, chosen as C1, and then all the elements in the heap is removed. So, for example, can you illustrate that one? You'll go back. The first one. There. Okay. Sige. Then you remove the one. How is that done in the algorithm? Explain to us how it's that done in the algorithm, removing the one there. James? How is that done? Can you describe the algorithm or the process there, how it's done? Parang it's easy to say, just remove. But in the algorithm, how is it done?
In the for loop, miss, when you initialize I equals 2 times n minus 1.
Huh? What? You said, John said, just remove, remove the one. So how is the one removed? That's my question. How is the one removed? It's very easy to say, click, click, remove all the ones. Okay, all the ones are gone. But in the reality, how is it done? So when you say remove, is it really remove or what? Ashari,
Miss?
how is the one removed in the algorithm? Can you describe? Don't give me the algorithm. Don't show me the algorithm. Just describe how it is done.
Nang you mean after when, sorry. Nang when you mean after like the winners like get promoted, like the
No, I did not
values
need that.
or
What I meant is John said that after you output the one at the root, so one, and then you
Mhm,
remove all the ones and then replace it with the next element, which is four at the
mhm.
bottom. How is it done in the in the code? Ralph, how is it done?
I think there's a if statement means that if there's a one variable, it goes directly to the variable list.
If there's one variable, no, I'm not talking
Uh,
about the one in the root going to the output list. The one John mentioned that it will be deleted all the way. John, can you go back to that, John? Nah. So there was a tournament and then one went all the way. One is the winner. It goes to the root and then it's copied to the output list. And then John said, remove all the ones. So with one click, na remove say 1111 there. My question is, sige, remove si 111. So the root, the ano, the second level, next level. How is that? How is that accomplished? The algorithm or in the, yeah, in the code of the tournament sort.
I think there's a function miss that if there's already a winner, then it removes all instances of
Yeah,
that
you have to
certain thing.
describe to me the function. Describe the function. What does the function do? So if there's a function, then describe the process of the function.
Can I try, Miss?
Go, Jan.
So we don't necessarily remove it. We overwrite it. So we know that one is the winner. So one is start was here. I didn't properly illustrate it here since it's an outdated example. But we set one here to infinite or some garbage value that you can easily distinguish. So we set one basically like it's gone, but no. So this is like a garbage value now, or infinite or whatever you want to distinguish it with. And
You
then there
cannot, John, you cannot put garbage values.
I
It
mean
must probably a sentinel value, which is
sentinel
bigger than all the given values there,
yeah,
like
like that.
max int or
Max in.
something.
And
And
then
then what will happen?
one
So
is still
how
there's
is that
still one.
determined? Kadit sa John, how is that determined? So kay 111, how do you know na 111 there? So from the root, at
From the okay. So what here. So we have no we don't what you call this?
you
Ah
don't actually.
no. You traverse through the heap and you look for the lowest number. Then that way once you
Wait,
found the
wait,
lowest
wait,
number.
wait, 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 wait.